Welcome to the deep dive. We're diving into the world of 3D printing today.
It's a fascinating technology, isn't it? Taking digital designs and turning them into actual physical objects.
Exactly. It's like magic, but it's real and it's changing so many things. It's also called additive manufacturing, right?
Yes, or digital fabrication.
Yeah.
It's all about building things up layer by layer. We've been looking at some really interesting sources that cover a lot of ground on 3D printing. Everything from how it works to the wild things people are making with it.
So where do we even begin? What are the absolute basics people should know?
Well, at its core, 3D printing starts with a digital design, a blueprint, if you will.
Like a CAD file.
Precisely. Computer-aided design. That's the starting point. Then the printer takes that design and essentially slices it into super thin layers.
And then builds it up layer by layer with some kind of material.
Exactly. And it's not just about making prototypes anymore. We're seeing this technology being used for mass customization.
So instead of mass production, where every product is the same, it's about making things specifically for each person.
Exactly. Imagine ordering a pair of shoes that are perfectly tailored to your foot, or a phone case designed exactly how you want it.
That's pretty cool. I can see how that would be a game changer.
And then there's the whole open source design movement.
People sharing their designs online for anyone to use.
Exactly. That's opening up all sorts of possibilities for innovation and collaboration. We're seeing 3D printing used in so many different sectors now. Agriculture, healthcare, automotive, you name it.
Wow, it's really spreading everywhere. It's like a quiet revolution happening right under our noses.
In a way, it is. And our sources really dig into some of the big implications of this shift. Like, imagine how much more efficient manufacturing could become.
Less waste, faster production times, that kind of thing.
Absolutely. And potentially lower costs in some cases. Plus, as we talk about, consumers could have much more influence over the design and production process.
More power to the people. It's exciting to think about. And I was also intrigued by what our sources said about the potential impact on logistics and transportation.
Right. If you can print what you need closer to where you need it, that could really shake things up. Less reliance on global shipping, potentially lower carbon emissions, even faster delivery times.
It's almost like 3D printing could help us rethink how our entire world is connected.
It really could. Now, to understand all of this, we need to talk about the different types of 3D printing technologies out there. Because it's not just one size fits all.
Okay, let's break it down. Where do we start?
Well, one common technology is called binder jetting.
Binder jetting? What's that all about?
It's a pretty straightforward process.
Huh.
Imagine you have a bed of powder, any kind of powder.
Okay, I'm picturing like a tray of sand.
Perfect. Now, a print head moves across the bed of powder and selectively deposits a liquid binder. It's like a glue that binds the powder particles together.
So it's like printing with glue and sand.
In a simplified way, yes. And it's surprisingly versatile. They use it to make molds for casting metal parts and even to create large-scale objects out of sand.
Really? Out of sand? I wouldn't have guessed that. What kinds of materials can you use with binder jetting?
Quite a few, actually. Metals, sand, plastics, even ceramics. It's a pretty adaptable technology. And it has some advantages. It's relatively simple, fast, and inexpensive. Plus, it can handle printing pretty large items.
Okay, binder jetting is in the toolbox. What else do we have?
Another interesting one is called directed energy deposition.
Now that sounds intense.
It does, doesn't it? This one is mostly used for repairing or adding material to existing metal components.
So it's like a high-tech welding process.
You could think of it that way. It uses a focused energy source, like a laser or an electron beam, to melt and fuse material onto a surface.
That sounds like something straight out of a science fiction movie. What's so special about this method?
One of the big advantages is the level of control you have over the microstructure of the material. That means you can create parts that are incredibly strong and durable.
So it's all about quality and precision.
Exactly. And it can be used with some ceramics and polymers, but it's mostly used for working with metals, either in wire or powder form.
Okay, so we've got binder jetting for versatility and directed energy deposition for precision. What's next?
Now we come to material extrusion. This is probably what most people picture when they think of a typical 3D printer.
The kind you might find in a school or a makerspace.
Exactly. It's very accessible and popular. This method works by heating up a filament of material, usually plastic, and extruding it through a nozzle.
Like a hot glue gun.
Sort of, but much more precise. The nozzle moves around layer by layer, building up the object based on the digital design. And you can even print with multiple materials and colors at the same time.
So you could print a model of a house with different colored walls and a red roof.
Exactly. FDM, or fused deposition modeling, is the most well-known example of this technology. It's been around since the early 1990s and is still widely used today.
And I remember seeing these printers use a special kind of support material. What's that all about?
Ah, yes, the support material. It's a clever trick. If you're printing something with overhangs or complex shapes, the support material helps hold those parts in place while they're being printed.
So it's like scaffolding for your 3D printed object.
The perfect analogy. And the best part is that the support material is usually designed to be easily removed after printing. You can dissolve it or just snap it off.
That's pretty ingenious. Okay, so we've got material extrusion for accessibility and versatility. What other techniques are out there?
Well, there's materials jetting, as the name suggests. It involves jetting tiny droplets of material onto a build platform.
It sounds like an inkjet printer, but for 3D objects.
You're not far off. But instead of ink, it uses a photosensitive liquid material. Each droplet is carefully positioned and then cured, or hardened, using UV light.
So it's like printing with light.
In a way, yes. And this technique is known for producing objects with a very smooth surface finish and high dimensional accuracy.
It sounds like it's all about detail and precision. What kinds of materials can you use with materials jetting?
A variety of polymers, ceramics, composites, and even some biological materials. Another quite versatile technology.
Wow, we're really building up our 3D printing toolbox here. What's next?
Now we come to powder bed fusion. This one's a bit more heavy duty.
Heavy duty in what sense?
Well, it involves using a powerful energy source to melt or fuse together particles of powder.
Okay, now we're talking real industrial grade stuff.
Exactly. This is the category where you find technologies like electron beam melting, or EBM, and selective laser sintering, or SLS.
Those names sound pretty high tech.
They are.
Yeah.
EBM uses a focused beam of electrons to melt metal powder, while SLS uses a laser to sinter, or fuse the powder together.
And what about selective heat sintering? I saw that mentioned in our sources, too.
Right, SHS is similar to SLS, but uses a thermal printhead instead of a laser. It's often used with polymers.
So powder bed fusion is all about melting or fusing powders together using different energy sources.
Got it. What other techniques are we missing?
We've also got sheet lamination. This one's a bit different from the others.
Different in what way?
Well, instead of extruding or jetting material, sheet lamination involves bonding together thin layers of material.
So it's like stacking sheets of paper to create a 3D shape.
A simplified way to think about it, yes. Materials could be paper, plastic, or even metal. And there's a really cool technique called ultrasound additive manufacturing, or UAM, which uses sound waves to weld metal sheets together.
Wow, using sound to join metal. That's amazing.
It is pretty remarkable. And finally, we have vat photopolymerization.
Okay, that one sounds complicated.
It's a bit more chemical in nature. This technique uses a vat of liquid photopolymer resin. It's a special kind of resin that hardens when exposed to certain wavelengths of light.
So you shine a light on it and it solidifies. Exactly. Stereolithography, or SLA, is one of the classic examples of this technology. It uses a laser to precisely trace out the shape of each layer, curing the resin as it goes.
I've heard of SLA printers. They're known for creating very detailed models, right?
That's right. And then there's digital light processing, or DLP, which uses a projector to cure an entire layer of resin at once. It can be faster than SLA, but the resolution might not be quite as high.
So SLA is for digital, DLP is for speed.
Oh,
Got it. Okay, we've covered a lot of different 3D printing technologies here. It's impressive how much variety there is. But what about the materials themselves? What can we actually build with all these fancy printers?
That's a crucial question. The material you choose will ultimately determine the properties and capabilities of your 3D printed object. And just like with any manufacturing process, the quality of the materials matters a lot. Our sources emphasize the need for high-quality, consistent materials that meet specific standards.
Makes sense. So what are the main types of materials used in 3D printing?
The main categories are ceramics, metals, polymers, and then various combinations of these.
Like composites.
Exactly. Composites are materials made by combining two or more different materials to achieve specific properties. Think of carbon fiber reinforced plastic, for example. It's lightweight, but incredibly strong.
Okay, so let's break down each category a bit, starting with metals. Why are they so important in 3D printing?
Well, metals are known for their strength, durability, and other desirable properties, like their ability to conduct heat and electricity. They're essential for creating functional parts that can withstand stress and wear.
So they're used in industries like aerospace and automotive.
Absolutely, but also in healthcare. for things like implants and medical devices.
What are some of the most common metals used in 3D printing?
Aluminum alloys are popular because they're lightweight and strong. Titanium alloys are prized for their biocompatibility and corrosion resistance, making them ideal for medical implants. Stainless steel is widely used for its strength and durability. And then you have more specialized alloys like cobalt chrome, which is often used in dental implants because it's very hard and wear resistant.
So there's a whole range of metals to choose from depending on the specific application. What about polymers?
Polymers, or plastics, are incredibly versatile and widely used in 3D printing. They're relatively inexpensive, easy to work with, and come in a huge variety of formulations with different properties.
So you could have flexible polymers for something like a phone case and rigid polymers for something like a tool.
Exactly. And there are polymers that are resistant to heat, chemicals, UV light, you name it.
What are some of the most common polymers used in 3D printing?
You've probably heard of PLA and ABS. Those are two of the most common thermoplastics used in desktop 3D printers. PLA is biodegradable and easy to print with, while ABS is known for its strength and durability.
What about more specialized polymers?
There are many. Nylon is strong and wear-resistant, often used for gears, mechanical parts. PEEK is a high-performance polymer that can withstand very high temperatures. And then you have flexible polymers like TPU, which is used in phone cases and other soft-touch applications.
Wow, there's a polymer for everything. What about ceramics? I don't usually think of ceramics as something you can 3D print.
Traditionally, ceramics have been difficult to work with because they're brittle and require high temperatures for processing. But 3D printing is opening up new possibilities with ceramics.
How so?
Well, some 3D printing techniques can create ceramic objects at lower temperatures and with more complex shapes than traditional methods.
What are some of the advantages of using ceramics in 3D printing?
Ceramics are known for their hardness, heat resistance, and chemical inertness. They're also biocompatible, making them suitable for medical applications.
So what are some examples of ceramics used in 3D printing?
Alumina is a common one. It's used for a variety of applications, from electronics to aerospace components. Zirconia is another popular choice, known for its strength and toughness. And then you have specialized ceramics like bioactive glass, which is used in bone regeneration and other medical applications.
It's amazing to see how 3D printing is expanding the possibilities of what we can create with ceramics. And what about composites?
Composites are all about combining different materials to achieve specific properties. For example, you could combine a strong but brittle material with a flexible material to create a composite that is both strong and tough.
What are some common examples of composites used in 3D printing?
Carbon fiber reinforced polymers are incredibly strong and lightweight, making them ideal for aerospace and automotive applications. Glass fiber reinforced polymers are a more cost-effective option, often used in consumer products and construction. And then you have more specialized composites, like metal matrix composites, which combine a metal with a ceramic or other reinforcement to create materials with exceptional properties.
So composites are all about tailoring materials to meet specific needs. Fascinating. But our outline also mentions special materials. What makes a material special in the context of 3D printing?
That's where things get really interesting. Special materials are those that are not typically associated with traditional manufacturing methods, but they can be used in 3D printing to create unique and innovative products.
Give me some examples. What kinds of special materials are we talking about?
Well, one example is food.
Food. You can 3D print food.
Absolutely. 3D printing is being used to create everything from intricate chocolate designs to personalized nutrition bars and even meat alternatives. It's still early days, but the potential for customized and personalized food is huge.
That's mind-blowing. What other special materials are out there?
Well, researchers are exploring the use of lunar dust as a potential building material for future lunar habitats.
Lunar dust. So we could potentially 3D print buildings on the moon using local resources.
Exactly. It's still in the research phase, but it's a really exciting possibility for future space exploration.
Wow, 3D printing on the moon. Sounds like science fiction. What else?
Another area of exploration is 3D printing with textiles.
So you could print clothing and fabrics.
Yes, and not just simple fabrics. Imagine 3D printing complex textile structures with embedded electronics or sensors. It could revolutionize the fashion industry and beyond.
3D printed smart clothing. The possibilities are endless. And what about smart materials? What makes a material smart?
Smart materials are those that can change their properties in response to external stimuli, like temperature, light, pressure, or even electric fields.
So they can adapt to their environment.
Exactly. They can change their shape, color, stiffness, or even conductivity.
What are some examples of smart materials used in 3D printing?
Shape memory alloys are a classic example. They can be deformed and then return to their original shape when heated.
So you could 3D print a stent that expands to the correct size once it's inside a blood vessel.
Exactly. There are also piezoelectric materials, which generate electricity when they're squeezed or stretched, and self-healing materials that can repair themselves when damaged.
It's amazing how 3D printing is allowing us to incorporate these advanced materials into everyday objects. And finally, what about bioink materials?
Bioink materials are specially designed for 3D bioprinting, which is the process of printing living tissues and organs.
So you're printing with actual cells.
Yes, bioinks typically consist of a hydrogel matrix that provides structural support for the cells, along with nutrients and other factors that promote cell growth.
What are some of the potential applications of 3D bioprinting?
The possibilities are truly transformative. 3D bioprinting could revolutionize drug development and testing, allowing us to create personalized models of human organs for drug screening. It could also be used to create skin grafts for burn victims, cartilage for joint repair, and even, eventually, entire organs for transplantation.
It's incredible to think that we might one day be able to print replacement organs. It's like something out of a science fiction novel. So with all these amazing materials and technologies, what are some of the real-world applications of 3D printing that are happening right now?
Well, the applications are incredibly diverse and growing all the time. It's hard to even keep track of all the amazing things people are doing with 3D printing.
Let's start with the manufacturing industry. How is 3D printing changing how we make things?
In countless ways. 3D printing is being used to create prototypes faster and cheaper than ever before. It's allowing manufacturers to customize products on demand, creating truly unique items tailored to individual needs.
So mass production is becoming mass customization.
Exactly. 3D printing is also enabling the creation of complex parts that would be impossible to manufacture using traditional methods. And it's reducing waste by only using the material that's needed.
It sounds like a more efficient and sustainable way to manufacture.
It definitely has the potential to be. What about the aerospace industry? How are they using 3D printing?
I know they're always looking for ways to make things lighter and stronger.
Exactly. 3D printing allows them to create incredibly lightweight and complex structures that would be impossible to manufacture using traditional methods. It's being used to create everything from brackets and hinges to fuel nozzles and even entire rocket engine components.
So it's not just about prototypes anymore, it's about creating actual functional parts for some of the most demanding applications in the world.
Absolutely. What about the healthcare industry? We talked about bioprinting, but what other ways are they using 3D printing?
I know they're doing some amazing things with personalized medicine.
They are. 3D printing is being used to create custom implants, prosthetics, surgical guides, and even dental crowns that fit perfectly. It's also being used to create models of patients' anatomy for surgical planning and training.
So it's about improving patient care and outcomes by tailoring treatments to individual needs.
Precisely. And then you have the construction industry.
It's hard to imagine 3D printing an entire building.
It might seem like science fiction, but it's happening. 3D printing is being used to create building components like walls, floors, and even entire houses. It's faster, cheaper, and more sustainable than traditional construction methods.
And you can create some really unique designs with 3D printing.
Absolutely. Architects and designers are really pushing the boundaries of what's possible with 3D printed architecture. And then there's the fashion industry.
3D printed clothing.
More and more. Designers are using 3D printing to create intricate jewelry, custom footwear, and even avant-garde fashion pieces.
It sounds like 3D printing is bringing a whole new level of creativity and customization to the fashion world.
It is. And what about the electronics industry?
I imagine they're using it to create more compact and complex devices.
Exactly. 3D printing is being used to create circuit boards, sensors, antennas, and even entire electronic devices. It's enabling the development of flexible electronics and wearable technology.
So we're talking about everything from smartphones to medical implants.
And beyond. And don't forget the food industry.
Right, 3D printed food. It's still a bit of a novelty, but I can see the potential.
The potential is huge. Imagine being able to print personalized meals based on your individual dietary needs and preferences, or creating intricate food sculptures for special occasions.
3D printed food art, it's amazing. And what about the energy sector?
3D printing is being used to create lighter and more efficient components for wind turbines, solar panels, and even batteries. It's helping to drive innovation in renewable energy technologies.
It sounds like there's really no limit to what 3D printing can be used for.
It really is a transformative technology with the potential to change the world as we know it.
But it's not without its challenges, right?
Absolutely. There are still technical, material, and economic limitations that we need to overcome.
Like what?
Well, one of the biggest challenges is speed. 3D printing can still be a slow process, especially for larger objects. And the range of materials that can be used is still somewhat limited compared to traditional manufacturing methods.
And the cost of 3D printing can be a barrier for some applications.
That's right. The cost of the equipment and materials can be high, especially for industrial-grade 3D printers. And there's also the issue of expertise. You need skilled operators to run and maintain these machines.
So there's still work to be done to make 3D printing more accessible and affordable.
Definitely. But despite these challenges, the progress in 3D printing has been remarkable. And there are some really exciting breakthroughs happening right now.
Like what?
Well, one area of intense research is multi-material printing. It's the ability to print with multiple materials at the same time, creating objects with complex compositions and properties.
So you could print a tool with a hard handle and a soft grip.
Exactly. Another breakthrough is in bioprinting. Researchers are making significant strides in printing living tissues and organs, with the potential to revolutionize medicine.
And we talked about the potential for 3D printing in space.
That's another area of rapid advancement. We're seeing more and more 3D printed parts being used on spacecrafts and satellites. And there's even talk of using 3D printing to build habitats on the Moon and Mars.
It sounds like the future of 3D printing is incredibly bright.
It is. But it's important to think about the broader societal implications of this technology as well.
What do you mean?
Well, 3D printing has the potential to democratize manufacturing, giving individuals and small businesses the power to create their own products. But it could also lead to job displacement in traditional manufacturing industries.
That's a valid concern. And there's also the potential for misuse, right? Like printing weapons or counterfeit goods.
Absolutely. As with any powerful technology, there are ethical considerations that we need to address.
So we need to be mindful of both the potential benefits and the potential risks of 3D printing.
Exactly. It's up to us to shape how this technology is used and to ensure that it benefits society as a whole.
So looking ahead, what are some of the key trends to watch in 3D printing?
Well, one trend is the continued development of new materials with even more specialized properties.
Like even smarter smart materials.
Exactly. We're also seeing a push towards faster printing speeds and higher resolution. And there's a lot of research into making 3D printing more sustainable and environmentally friendly.
It sounds like the future of 3D printing is all about innovation and pushing the boundaries of what's possible.
It is, and it's an exciting time to be following this technology.
It really is. So to wrap up our deep dive into the world of 3D printing, what are some of the key takeaways for our listeners?
I think the main takeaway is that 3D printing is a truly transformative technology with the potential to revolutionize countless aspects of our lives.
From how we make things, to how we treat diseases, to how we explore space.
Exactly. It's a technology that's still evolving, but the possibilities are endless.
And what about those aha moments? What are some of the things that really stood out to you as we explored this topic?
For me, it was the realization of just how much impact 3D printing is already having on so many different industries. It's not just a futuristic concept anymore. It's happening now.
And for me, it was the potential of 3D bioprinting to create personalized medicine and even replace damaged organs. It's truly mind-blowing.
It is. So to our listeners, we encourage you to think about how 3D printing might impact your own lives and the world around you. What possibilities does it spark for you?
And as this technology continues to evolve, what unexpected applications might emerge that we haven't even imagined yet? Thanks for joining us on this deep dive into the world of 3D printing.